So yeah, it's the first time, and it's 5 to 10 minutes. Is that correct? Is there a timer as well, or I don't know? I'll start. Exactly. Where's? I'll know when the time is up. I'll be notified. So actually, this is kind of a cross between the previous two talks. I didn't know the themes, but it's actually quite fitting, but scaled down to a hobby level. So it's not enterprise. It's about my adventures with my small, tiny Raspberry Pi at home, trying to figure out why it's leaking memory with my Node applications. So therefore, I wrote a small monitoring application in Node. Well, who mind, that doesn't matter. It's a lightning talk. Let's talk about Node. So what did I do? Well, I wrote a non-enterprise server monitoring package for Raspberry Pi. It's just started, but...
Will it run on my BG board?
Well, it's a Linux based, so yeah, it's probably so. Yeah.
VI versus Emacs.
Well, I get a number of those pies for the price of a beagle, I guess. So let's not talk about that now. So why there are a lot of server monitoring packages out there? So why write one? Well, I installed the standard one, round-robin based, RD-based tool, and I got this. So the only thing running here is the monitoring package trying to. So the monitoring is clearly affecting the system. So so that's, you don't want that. You want something like this. Well, you see peaks here, but you see peaks at around 0.3% of CPU utilization. You see a load average less than 0.06 with the other, I will not name it, package. I had a load average of 1.3 just running the monitoring application, so clearly it wasn't good. And I made some observations, nothing fancy here, but especially on the Pi, I/O is extremely expensive. So basically your main storage is an SD card, the stuff you have in cameras, which is optimized to write pictures in a huge chunk and not salt and pepper writes. And your other alternative is to write in a USB drive, which sits on a network interface, or an I/O interface, which also is the network card. So it's going to be very slow. Most clients are a lot more powerful than the server in this case. And the RD-based tool, well, as you can see, it for each of this is not only taking measurements, it's also generating these fancy images as PNGs in case I need them at some point in time for all the graphs. So clearly, if I have a browser on this Mac, it's a lot more powerful. It can render the image and when I need it. Also, when you go to look at well, the Munin, Ganglia, Graphite. You go to these sites, they are targeting an enterprise size operation. So like in your server farm, you simply install these clients on your nodes and it'll all come together in this powerful calculation. Well, I only have a really small computer, so I don't need that, so it's overkill. Oh, sorry, I'm trying to find my way through my own presentation. So the solution I concluded was that we don't want I/O, and I agree with the previous speaker that you don't want to lose logging data, but on a hobby project, if you can go from 60% CPU to basically zero by not writing on your SD card, I'll take that. Offload the CPU, don't render graphs that you don't use, and don't enterprise it. So, well, working over 15 years in Java, one of the big, well, as a developer, you want to maybe a factory here, or maybe a factory for the factory, and that could be the config file just to set up the Spring configuration. That will, well, it's overkill in this circumstance. So I wrote this. It's a really simple program called round robin database in Node. It keeps in-memory archives. So it's a little. I didn't know about React before, so it was interesting. Thank you. Maybe I should have read up on React. Because anyway, so it keeps memory archives, which is basically one archive for each graph. And then you want to aggregate those to get, well, a history of time. So aggregating up a chain of buffers. Basically, so if this is an archive, I have round robin buffers, and when they go full circle, it'll apply some aggregation method and throw data over in the next bucket, which will then do round robin. So this way you also get a fixed memory size, which is well, with this method you know how much memory your monitoring will consume, and you know how much I/O it will consume. So I believe it's fit for this purpose. I added a few aggregation strategies. So average typically being a very interesting one, max min of the previous bucket, and the sum to do counters, etc. It stores to disk periodically, so it does everything in memory, and then it writes the whole database to disk, which is good for the SD card scenario where you don't want small writes. You want something that looks like an image write to the SD card. And it's lightweight, so there's no dependencies at all. I didn't import anything, so this is pure Node out of the box. How do you use it? There is no, this is how you start a database. It's for embedded use, also to be lightweight. You don't want the process to store your monitoring data in this case, so it's made to be plugged into your monitoring application, but it's, I would say it's probably not best practice JavaScript because it's not so functional. It's very object-oriented. So you create your database, you create a couple of archives. You name them to something you will remember. You can, of course, persist it to disk, save it. I'll show this in a second. On my own time. And then adding, it's simply name your archive, add your data. You could either do this or submit a timestamp, otherwise the local server time will be used, and you get the whole data out as well. So typically this will be very small amounts of data. It's kilobytes, not megabytes of data, so that's fine. You can see it on GitHub, of course. I'm working on the monitoring application. This is what I'm going to show today, because the database is not so interesting, and it's already on NPM. So I consider this early but stable. So it passes all the tests, and it's been running for almost a week on my at home without crashing. So it's good to go. Yeah, short term. I believe I have like 2 minutes or something. So, oh, sorry. Need to find my way out of this. So yeah, what does it look like? Yeah, let's start with what does it look like. This is what it looks like. This is my Raspberry Pi at home. So typically, this is the monitoring application, and these are the buckets that's serving it. All the graphs are rendered in the browser, so I'm using Rickshaw. I don't know if you're familiar with that. It's a graphing library on top of D3, and just getting all the data in JSON format and feeding it into Rickshaw, which doesn't have time zone support on the axis, so everything is in GMT. And I was really confused at first because I was looking at, I knew I'd done something, but the flank of the graph was at like 2 hours before, and I was like, no, what? Yeah, I don't know. The actuals are not so interesting. Well, there's one interesting. So here we can see the node process running, and there's some weird things going on here. It's like jumping up every. Yeah, this is at 8 o'clock in the morning, and then the next day at 8 o'clock in the morning, it makes another job. I have no idea. So this is, but today it's been stable. But if you look at the memory consumption on the machine as a whole, it goes down. So, well, so or not the memory. The memory consumption goes up. Free mem goes down. It's not correlated to the only process running Node. So something weird is happening. But that's not the topic. So let's, before I end this lightning talk, just get a quick look into what it looks like. So this is me reading the conf. So this would be an applied example of using the database. So either there exists a DB file on disk, create it. Otherwise, well, there was no database. He wants a database, create it. And by the way, you can configure it to run in memory completely, so no persistence at all if you just want to do memory. So some functions to collect some memory, and then I do set interval, my function, and the configured interval. So that's basically it, and then make a small HTTP server to serve the data. And this, again, don't enterprise this. So I was like, oh, this is REST web service. That calls for Restify. NPM install. No, wait. Like there's a lot of HTTP support in Node out of the box. And if you know that the only calls that will come in are calls that will be the name of a bucket, well, then you can actually write the small function or do get, parse out your key. You can see here, it's very refined. We know this be slash bucket name. So let's remove the slash and serve it. Yeah, and I think that's my time. So that's it.